So what we look now at is how we can use the ESP. And I think when we get it out of the box, there is a set of stickers. I'll put them here. And there is also the chip. And I'll show you sort of first about the chip and the stickers. And let me get a close-up here. So what you can see here is over here. So what you can see here is we have these stickers. There are numbers on there, and I've got this breadboard. Now, if we look at the back side of this chip, we also get the names and numbers. So what you can see is sort of GND and so on. So this starts with GND 3 volt, and if we go a bit closer, get sort of VX, and then we have 13, 12, 14, and so on. So I look now for this one, which has the, and this is sort of the upper row, what I have here. And so what I do now is I put the upper row onto this one. Let me just put the camera down here. Okay, this is not going to work, so let me switch to the other camera. So what I do now, I put this onto here, and I'll show you then in a minute how this looks like. So I make sure this is the right one. It ends with 36. So I make sure to have this just here in the right place. This helps us later. This makes a lot of things easier. We don't have to look underneath the chip, which we can't really do once we have put it onto the board. And otherwise, we would have to always look up on the thing. And so I switch back to the close-up camera. And what you see now is we have this here on the side. And now it's very easy to see this. Now what we do is we plug this into the breadboard. And the important thing is you need to have one row on the outside. So the breadboard is one row wider than the chip. So look at both sides. There's at both sides one row left. There's one row left, and I plug it in here. If you plug it in, don't press on the display, press on the side. And what you see now is I've pressed it in, and you can see there is one row of pins where I can put a connector in. And here's the same, there is one row of pins where I can put a connector in. So with this, we have now the chip connected here to the board. And this is a good starting point. So I switch back to this one, and now let's have a look how we take it from here. So I put this aside. So we have now connected our chip, and I can also connect now the chip to the serial line, to the USB port. Let's have a quick look this way around. So now I open the IDE, which we have here, and now let's have a look. It's COM4 in our case, and this is nice, it's working. Now we want to use the digital output. How do we do this? The digital output, I've got a plan here. This is sort of something I look now online for as well. So the digital output, we have to check which of the pins we can use for the digital output. So let's go to the web browser, and what do I want to look for? It's ESP32 WebKit. This is basically what it says on the package. Heltec, and we are interested in the pinout, and it's on their webpage. So we have a quick look at. So here is the documentation, and here is the pinout. So let's go here. So we have the pinout, and I keep this open because this is really what we need when we look at what pins we're going to use. And what I'm going to use now, I connect an external LED. The internal LED is connected to pin 25, and I just use the next pin and connect the external LED. What do we need if we connect an external LED? We need an LED, and we need also a resistor for connecting the LED. So I quickly draw first what we are going to use. So let's start with this. So if we look at this, and if you look on the screen, we have here on the screen pin 26, and I connect this, and I have pin 26 here as well. So let's first start to connect this. So pin 26, what do I connect onto pin 26? I connect an LED. This is the symbol of an LED. It lights, that's why the arrows go outwards, and this is the symbol. And the LED has two sides. This is the plus side, I marked this here. This is the minus side. So the minus side, you can really easily remember, that's basically where the 1 dash is. This is the minus side. And now, in order to make this work, we have to connect it with a resistor. So the resistor restricts how much current goes through here. And so I put a resistor on here, and I put it to ground. So this is the very basic thing we're building. And if we have a resistor, the current that goes through the resistor is dependent on the voltage on the resistor as well as the resistor itself. So there is this common equation, R is U divided by I, and we can also now look, U is R times I, and typically we are interested in the resistor. So I give it away here. So for our LED, we want to have 20 milliamps, which is 0.02 amps. And our voltage on the chip is 3.3 volts. So this chip runs with 3.3 volts. So I write it in here, 3.3 volts. So the whole voltage from here to here is 3.3 volt. And let's have a look if we can measure this if I take the multimeter. So just a sec. So this is the multimeter we have, and you have to first put the cables on. They're still together. I do that here. And how do you connect the cables? So there is COM, which is the black cable which goes in the middle. And then there is plus, which goes into V. So we connect it this way. And now we want to measure voltage. How do we do this? There is voltage here and here. Here is alternating current. We don't use that. We are interested in this side. And I put it to 20 volts because this is more than we need. Be careful with the multimeter. The problem with this one is it doesn't have an auto switch off. So you may need to change the battery if you forget to switch it off. So now I put it here, and now let's first start. I put the black one to where it says GND, which is ground, 0 volt. This is the very top pin, and next to it there is the 3.3. And what we see here, I get 3.29 volts. So this looks good. That is the chip. And let's see what I get here. Interestingly, here it says 5 volt, but I also get 3.3 volts. That is interesting. And now let's have a quick look on the other side. There should be 5 volt and ground here as well. they seem to be not connected at all. And I think that's why it's quite useful to measure those things. So what we see here is we have ground and we have 3.3 volts. That's great. So now what we need to look at is our resistor. How big does our resistor have to be? And now the question is the current that goes through all the way. So it's the same current through the LED and through the resistor. And so for the LED, the current we're looking for is about 20 milliamps. How do I find that out? So I think that's something you can remember or know, or you can just look it up. If you look for a data sheet of a resistor, then you can find this. And let's just Google for a data sheet. Where's my mouse? Oh, here it is. So let's have LED data sheet, and let's go for the 5mm red. Here there's a SparkFun page, but here let's just take a random data sheet. I'm not sure if this is going to work. So here we have a data sheet. And yeah, it says about the LED. And here we see forward voltage. That's sort of the voltage we have on the LED. At a typical I is the current, and here it says 20 milliamps, and then we have typically 2 volts. So if we draw this again, let's have a look here. So when I switch back to the other frame, so what we have here, there are 2 volts here. Here there are 2 volts, and so as it's in total 2.0 volts, as it's in total 3.3, we have 1.3 volts along. So we could draw it in a different way. We could draw it like ground, then we have the resistor, and then we have the LED going this way, and we have here pin 26. So this is sort of the same thing. We could draw it that way. And now what we can do is we know it's on the total, the whole thing is 3.3 volts. And this is a voltage divider. So, and we know it's 2 volts, 2.0 volts on the LED. So we know it's 1.3 volts here. So this part, because 1.3 plus 2 volts is 3 volts. So this is sort of what we know. Now what do we know? We know it's 20 milliamps, and we know the voltage is 1.3 volts. So we can do R is equal U divided by I, and in this case it's 1.3 volts divided by 0.02 amps. And I quickly get a calculator, and then we have a look what we have if we have a calculator. So you could also already try to calculate it in your head. I just make sure that we don't miscalculate this here. So let's have a look. We have 1.3 divided by 0.02, and this gives us 65 ohm. So this is 65 ohm. And now the interesting thing is when we do prototyping, it is not really, it doesn't really require much precision. So basically any resistor between 50 and 220 ohm will work. Your LED will be not exactly in the right brightness level, and I think we can see this here. If we look into the data sheet, there it shows the forward voltage is changing with the current. Also, light emission is changing. But as we just build a prototype, we don't really have to care. So I'm looking for a resistor that fits roughly this, and I'm looking for some LEDs that we can build that up. Just a second. What I have now, I have a green LED. We'll look closer at this because the LED has two legs of different lengths. The longer one is the plus side. And here we have different resistors. And now what I could do is I could look at the color code, but as I have the multimeter here, what I do is I just put the multimeter to ohm, which is this one. And let's quickly check what we see here. So this is 200 kilo ohm, so it's 1 kilo ohm. Let's try this one here, if this is correct. So this is 1 kilo ohm, and so what I do is I don't have to measure it each time. I just write it here. 1K. Let's measure the next one. This is 200 ohms. Probably it's 194, it says, but I guess it's 200. So I put 200 and I put R. Some more, so let's have a look here. This is 100 ohms. 2 more to go. Okay, this is a bigger resistor. So let's put to 20K. Okay, this is 10K. Then this here should be the 1K. Let's have a look. No, 1K we had already. So this one is the 330 ohm. So this is sort of what we see here as well. So I recommend you to just write it onto this. And as we said, what do we want? We said around 100 ohm will be nice. So I used the 100 ohm resistor. And now I built this up. And I think for this, we have a closer look at the LED. I go for the close-up. So if we now look at the LED, one leg is longer than the other, and the longer one is the plus side. So if we look at our schematic, the plus side is the longer leg, the minus side is the shorter leg, and you can remember this very easily. Plus has 2 dashes, minus only 1. And here is the resistor. And so how do we do this? So what we do is we build up our schematic as we have it here on the second board, and I get the second board here. And let's have a look how we do this. So what we do is, so interestingly, they are connected this way. So always this way is connected. So along this side. And I have another breadboard, just a second. So I have the other breadboard, and this breadboard is just the same as another one, but it's taken apart. So I have taken the back side off, and what we see here is how they are connected. And if we look very closely, we see they're sort of short ones this way and longer ones this way. And if we look at the front side, so those things are connected this way, and those are connected this way. And if we look here, so this is sort of how we have it. Now, let's build our thing. So we have something which we connect later to ground. And in this, we connect the resistor. So I connect it now in row 5 and in row 15. And from the LED, I need the long leg going towards plus, the short leg goes into 15, the long leg into 20. So what I have now here is if you look very closely, they are in the same row because they are overlapping. And this one is in another row. Now what do I need? I need cables. I need male-to-male connectors. And I have here a few short ones. So the LED side, I want to connect to pin 25. And look where I put this in here. I put it into the same row. And if you remember, so basically they are already connected. So this goes into row 26. And this is sort of where we have it here. So this is 26. You can see it here. And the other one goes into ground. And usually we should use a black cable there, but I just found this one. So this goes into ground. What we have now is, if we look here, we have exactly this one, ground, resistor, LED, and we have the LED the same way around. So we have built this up, and now we have built the hardware. Let's see if we can now get it started and program it. So, okay, so when I switched the multimeter off, because I said earlier the multimeter doesn't have this auto off function, which is a pity. So you may at some point need to replace the battery, because if it's on for a day or two, it will not work anymore. Okay, so now how do we program this? So it's the ESP32, so let's go to MicroPython. And there is the documentation. And in the documentation, we find how to program pins and GPIO. So this is what we had earlier. So I put this here. Don't need a calculator anymore. And now I have the MicroPython environment here. And let's put this way. So now, what do we need? First, we need from machine import pin. And now we call it X LED is, and I connected it, if we remember right, to pin 26. Pin 25 is the internal LED. And I want to have it as output. And now let's see what happens when I switch it on. So let's do that. X LED dot on. And now we see the external LED is lit up, and I try again. So let's do X LED dot off. And so I can switch it on and I can switch it off. Now what happens if I put the LED the other way around? So let's try this. I put the LED the other way around. Now if I switch it off, nothing happens. If I switch it on, nothing happens. Let's have a quick look at why this is the case. So what I did now, I had still ground here, the resistor here, and I put in the LED this way to pin 26. And so what we see is now it's plus here, it's minus here, and this is against the direction of the diode, so it's not working. But what else I can change now? I change this for 3.3 volts. Then what happens? So let's do that. I put this in at 3.3 volts. Now let's see what happens if I program. So if I go here and I say LED on, nothing happens. But if I say LED off, it's on. I think that's interesting. So what happens? If I switch this to on, this is 3.3 volts. If I switch it to off, it's equal to ground to 0 volt. So what happens now? Now it's the other way around. And if I'm 3.3 and I have 0 here, the LED works the other way around. So we can build it in either between ground and the chip or between plus and the chip, the pin. And in this case, when we put it between the plus 3.3, like the voltage the chip has, then it's on when we switch the pin off, or it's off when we switch the pin on. Here, if we put it between ground, and it's basically when we switch it on, it's 3.3 volt here and 0 here, and the chip and the chip drives the LED. So that's what we also saw when we initially tested the ESP8266. It's just the other way around. So I can put the LED either between ground and the pin or between plus and the pin, and the only difference is I have to look is sort of the voltage the right way. So if it's high, and we say high is sort of the higher voltage and low is 0 volt, so it just may turn this around. So this is important to know. Now let's do one more thing here, and you can experiment with this a little more. So let's have the LED blink. So we have it now the other way around. I put it back to that we have it in the original one with ground, and I have to turn the LED around. So let's try if it works. If we put it now on, it's on, and if we put it off. Now we want to have the LED. So I lost that camera. Okay, so those cameras switch off after 30 minutes. So so what I can do now is I want to have the LED blink. And in order to do that, I can use the command sleep. So I have to import it from time import sleep. And now if I call sleep, it just waits for the time. And I can now do a loop. So while true, and this is something Python specific, the colon, and then the editor here already does the indentation. This is something if you don't use Python, that was sort of the first thing I really was surprised that somebody would design a programming language where the white space matters, but it does. So now we are inside the loop, and in order to get in order to get out of the loop, we just have to go back to the first line. So what do? We say external LED dot on. Then we say sleep, and let's sleep it 1 second. And then we say external LED off. And let's say we sleep then for 0.5 seconds. Now we have a loop. Let's see if this works. And here nothing happens because we're still indented in the loop. So I go back and I do this. And now what we see is the LED is blinking, and we have our first program. So what is this? We have written this interactively in the interpreter, so we don't have a file which we can download, but that's something we'll look later. So what we have now is an LED that's blinking, and we can change the speed by having the sleep command changing. And we could now also look to add more LEDs. We could add an LED to further pins, and I think that's the last thing we look at here. So if we look here at the pinout diagram, there are more. So I could also connect something to 27, to 14, to 12. I could also connect something to 35, 34. I think I should not connect things to something where the OLED display is connected to, because then the OLED is later not going to work. But we'll look into this. So with this, we can do a output. And the next thing is we look how to pulse this very fast. And this is then to change how bright the LED is or also to control a servo, but that's in the next video.